In this video, we continue to learn about the basics of branching. I'm Karen Agar with the University of Georgia, and this system was created as a part of SAIL-CS, the System for Adaptive Intraspace Learning for Computer Science. Sometimes continuing execution of a program can be pointless or even harmful. System.exit0 is a command that allows us to terminate a program without generating an error. Let's look at an example of how you can use this. So here's just a basic example that's going to compute an average. So I've initialized a variable int sum, which is going to be the sum of all grades, and int num students, which is how many students we're going to divide that sum by. At the end, you can see that I'm trying to print out the sum divided by the num students. We're going to get these values from the user, so I'm prompting them to enter the sum and the number of students and then reading in the int values. So if I run this, there's nothing wrong with this program. It works as expected. If the sum of all grades was 300 and the number of students was 3, then it's going to tell me that the average is 100, which makes sense, right? Now, we're talking about the command that allows us to terminate a program without generating an error. Why would this be useful? Well, in this case, if I were to run this program again and enter a sum of anything, 300, but let's say the user maybe messed up and entered the number of students as 0. It breaks our program, right? It gives us an exception in thread main, and oh, we tried to divide by 0. So now that we know about branching statements, we can use an if statement to handle cases like this. Right before we actually compute what could break the program, I'm going to say if our num students is 0, then I'm going to exit the program. So system.exit 0. Now, what this does is that if a 0 is entered here, it's going to terminate the program. And even though this line is the next line in the flow of control, it will never be seen if num students is 0. So let's run this again. And I'm going to do the same thing, 300, 0 for the number of students. Now, when I push enter, you can see nothing happened. Now, my red square is not lit up, meaning that the program execution did terminate. So this is a really good, useful tool to be able to control when you terminate execution of a program. So next we're going to talk about the conditional operator. I've got an if statement that says if n1 is greater than n2, then assign max the value of n1, else assign max the value of n2. So it's taking me 4 lines here to assign max the value of either n1 or n2. For short branching statements like this, there's actually a shortcut. So this line accomplishes the exact same task. This is called the conditional operator, and the way that it works is given this same Boolean expression, so you don't have to change the way that you're writing those, it's going to evaluate the Boolean expression, and then you can see we have a question mark here. If this Boolean expression evaluates true, then this value immediately to the right of this question mark that we see here will be returned. Otherwise, so if this statement returns false, this value immediately to the right of the colon will be returned. So back to the way that we've written it here. So if n1 greater than n2 evaluates true, then n1 will be returned and max equals n1. You can see that's the same thing here. Else max is going to equal n2. So this is a quick way to write short branching statements, and you're combining the question mark and the colon together, and it's called the conditional operator. So here I have a little program where I ask the user how many siblings they have, and then I read in that int from the keyboard and store it in this int num siblings. I then print out you have whatever number they tell me plus the word sibling and siblings. So you can see here that I entered 1, and it says you have 1 sibling or siblings. So what I want to do is use the conditional operator here to determine which one of these words is the correct one to print out. So really what we're trying to say is if they enter 1, then you really only want this singular word. You have 1 sibling. But otherwise, if they enter 2, 3, 4, 5, then you would want the plural version of this word here. So if num siblings is 1, print sibling singular, else print siblings. So I'm going to first, instead of hard code this here, I'm going to concatenate a string. So I'm going to just call it sibling. And I need to actually create this string. So here's string sibling. And I want to set it to one of these two values, sibling or siblings. And So the Boolean expression that I'm going to use is if num siblings is greater than 1. So I don't need the word if because I'm going to use the conditional operator. So I'm going to say num siblings is equal to 1. Then if it evaluates true, so if there's only one sibling, then I want the word sibling. Otherwise, so for any number of siblings other than 1, I want the word siblings. Now I'm going to add a space here just so it looks pretty when we print it out. And you can see here that now I'm going to print out you have whatever number they tell me plus either sibling or siblings. So let's see if this works. I have 1, you have 1 sibling. And if I do 5, then you have 5 siblings. Note that since all this conditional operator does is return a string, I could have just avoided creating this extra string variable and placed this entire conditional operator inside my print line statement. So I'm going to just copy this here, get rid of my string sibling, and in its place, I'm going to just paste my conditional operator. You will need to enclose this in parentheses in your print line statement, but this should work exactly the same. In our Basics of Branching video, we looked at all the different Boolean operators. At this point, we've gotten a good bit of practice in with the greater than or less than operators, but we need to practice a little more with some of the other operators like the and the or operators that are used in compound Boolean expressions, or the negation operator that negates the value of a Boolean expression. We'll also look at a new operator that was not discussed in our previous video, which is the exclusive or. Then we're going to revisit the comparison operator, the double equal sign, and look at when we can use it, when we can't, and what we use instead when we're not allowed to use equals equals. So this is called a truth table. And the way that this works is assume that we have two different Boolean type variables, A and B. So for each one of these rows, we're going to assign A and B different values. So here we've got every different possible combination. We've got A and B both being true, A being true, B being false, A being false, B being true, and A is false, B is false. So for each column, we're going to address a different Boolean operator. This first column is going to look at the AND operator, where we're combining A and B, and we're going to assess what the truth value is of this entire expression, given the truth values here of A and B for each row. So again, remember that this double ampersand sign is called the AND operator, and this entire expression evaluates to true only when both expressions are true, meaning that in this first column, A is true, B is true, so A and B evaluates to true. And if we look at the rest of these rows, we never again have the situation where both A and B are true. So our resulting table looks something like this. True when they're both true, false otherwise. For this next column, we're going to look at the OR operator. Remember, the OR operator is the combination of these two vertical bars, and this entire expression evaluates true if either A or B is true. So in this first row, I have A and B both with the value of true. This entire expression is going to evaluate to true because we need one or the other, but both also works. Similarly, in the next two rows, we've got at least one that has the value of true, so either A or B is true, so both of those are also going to be true. In the very last row, though, we have both false, so that will be our only instance where we have false in the truth table. So now we're going to learn about a new operator that was not discussed in the Basics of Branching video called the exclusive OR. You can see here that it's this little caret symbol, and it's called the exclusive or the XOR for short. Now, unlike the normal OR that we just looked at, the exclusive OR says that the entire expression will be true if either expression is true, but not both. So in rows 2 and 3, when I have only A or B being true, then A exclusive OR B will evaluate to true. But when they're both false, like in the last line, or when they're both true, like in the first line, then A exclusive OR B is going to evaluate to false. And finally, we've got the negation operator, which is the exclamation point. And so whenever we put this in front of a Boolean expression, it's going to negate the value of that entire Boolean expression. So it's called the negation operator, also called the not operator. So I read this as not A. So here we've got A being true, so the negation of that is false. Similarly, here we'd get false. And then in the last two lines, the negation operator is going to be true. Okay, so now we're going to talk about using the comparison operator equals equals. So we've seen that equals equals is appropriate for determining if two ints or any of the other primitive integer types like longs or bytes are the same. Also for booleans or chars to see if they have the same value. And we've looked at a couple different examples of things like that. We've said that you cannot use equals equals when comparing floating points, so floats or doubles, or any object, which includes a string. So why can't we use equals equals to compare floating point values? Well, remember that floating point values are really just approximations. Whenever you're dealing with a decimal point, somewhere in that decimal point it could be rounded, and it could be different with two different systems. So it's really better to specify a threshold that you don't want two values to be different by. So maybe doing something like this if statement here. You're checking to see if the difference between two values, A and B, are less than some value, epsilon here. So you could have something like if the difference between A and B was less than 0.01 or something like that. So notice here that I'm using absolute value because A minus B could have come back to be negative. So I'm just using the absolute value function here to handle the negative values. We've also said that equals equals should not be used to compare objects. So suppose we have two different objects, S1 and S2, and let's say that these are string objects because that's what we're pretty familiar with right now. What's actually stored in S1 and S2 is their memory address, not the actual text of the string. And what our comparison operator equals equals checks is if what's actually stored in that variable S1 and S2 match, meaning that if I said something like S1 equals equals S2, it's going to return true if and only if S1 and S2 hold those same memory addresses in these variables. So even if S1 and S2 are string variables that have identical strings inside, if those strings are stored in different memory locations, then that's going to return false. Let's look at an example to kind of put this into context. Okay, so here I've created two different strings, S1 and S2, that contain the exact same text, just the string Java. Now we've said that this comparison operator equals equals is really going to be checking if S1 contains the same memory address as S2. So it's not actually going to be looking through the letters to see if they're the same. Now, the interesting thing here is that Java's actually gotten pretty smart. In order to best utilize space, it can actually figure out sometimes if these strings are actually the same thing and end up storing them at the same memory address. So if I were to actually run this, again, Java's pretty smart and figured this out. It's going to tell me true that these things are equal. So what that actually tells us is that S1 and S2 are both pointing to the same memory location where the word Java is stored. This occurrence where Java figures out that multiple variables are pointing to the same string and therefore just points both variables to the same memory address is known as interning. There's nothing special about the word Java. This would work the same if we had the same text, hello, here. So run it again, and it says true. Now you may be asking yourself at this point, well, why can't I use equals equals to compare strings? It seems like it works. Well, if I were to concatenate these strings, let's say I have another string S3 equal to world. Let's say I concatenate these strings, so S1 plus equals S3. Now what we're doing is we're concatenating world onto the end of this, so it should really say hello world. And then do the same thing for S2. S2 plus equals S3. We can then even print out S1 and S2 just to make sure that they do in fact contain the same text. But now it will be interesting to see if S1 and S2 have the same memory locations. So if I were to run this, you can see that S1 printed out hello world, S2 also printed out hello world. We can see that the text is virtually identical, but we get a value of false here, meaning that once we started doing things like concatenating, then the computer could no longer figure out if S1 and S2 in fact held the same thing, so they were assigned different memory addresses. So the equals equal sign is not reliable here. to truly test whether two strings or any other types of objects are in fact equal. So since the comparison operator is not a good option for comparing strings, we do need a way to be able to compare two different strings and see if they're equal. So luckily, the string class provides us with a method called equals. So instead of saying s1 equals equals s2 here, I can say s1 dot equals s2. Now the ordering of these two does not matter whatsoever, and this equals method actually returns true or false whether or not the values are equal. So if I run this now, then I get the value of true, which is what I was looking for here. Now let's test something out with this. Let's see if I were to change S2's hello to have a capital H. They're pretty much the same, right? Other than one has a capital letter, one does not. So I wonder if the equals method is going to tell us true or false. And if we run it, you can see that, oh, they're not the same with this equals method, which makes sense because they're not actually the same. There is a difference, right? But sometimes you may want to determine if two strings are the same, ignoring the case of the letters. Luckily, there's another method defined for us called equals ignore case. Pretty self-explanatory that it's going to check whether S1 equals S2, ignoring the case of any letters in the string. So if I save and run this, now we can see that these two are equal to each other, even though there's a capital and a lowercase h. Again, I can make any of these letters have different cases. So I capitalize the L here and the O here, and if I run it, it's still going to tell me that it's the same. So we saw that we could use the equals and equals ignore case method to compare two strings and see if they're equal. Well, this also works for other objects. So the equals method can and should be defined for each class. Later on in the semester, when you guys will be creating your own objects, you will define your own equals method. So the programmer will specify how we determine if two objects or if two different items of a class are equal. More on that later on. So for strings, equals checks to see whether the characters are the same in each string, unless you use equals ignore case, and then that just ignores the case of the characters. Sometimes you may want to compare two strings, but no more than just if they're equal to each other. So there's another method with the string class called compareTo, and it compares two different strings, telling you which one comes first in lexicographic order, which is like alphabetical order, but a few more rules because of capital letters and numbers and symbols and things like that. So this method compareTo, unlike the equals method, doesn't return a true or false. It's going to return a number, some kind of numeric value that helps you identify which of these two strings, the one calling the method on the left, or the one being passed in as the argument inside the parentheses, comes first in lexicographic order. So what exactly do I mean by lexicographic order? I'm talking about the alphabetical order that Java recognizes. And this is actually the alphabetical order that is in the ASCII chart. So a couple little rules that you need to know is normal alphabetical ordering applies. So the word ant here would precede the word bug. A precedes B. Simple things like that. But also capital letters are going to precede lowercase letters. So here, cat with a capital C precedes cat with a lowercase c. And then finally, substrings are going to precede a larger string. So here he is part of the string of hello, and so he will precede hello. Okay, so here I've got two different strings, S1 and S2 declared, and I'm going to be giving these strings different values, and we're going to use the compareTo method to see which one of these comes first. So let's set S1 equal to he and S2 equal to she. Now we know in alphabetical order, right, which is the same here, that he is going to precede she. Let's make a print statement, system.out.println, and I'm going to use this compareTo method, s1.compareTo s2. I could have done either order here, but remember that the order you put these in will affect the outcome. So we said that he, because of a H here, should precede the word she, because H comes before S, right? But what is this going to print out? It's not going to print out a true or false or the words he precedes she. We said it's going to print out a number value, right? So a numeric value. Now the easiest way to remember the number value for me is that if this first number, S1, wins or precedes the other, then it's going to print out a negative value. If they're exactly the same, so there's no difference, a 0. And if S2, or whichever string is in the parentheses here, precedes the other, it's going to print out a positive value. So this is really just like a negative to positive scale here, and this kind of helps me remember how that's going to function. So since S1 is the word he, then we know this should precede S2, so we should get a negative value here when we run it. So let's run this program, and we do. We get a negative value. Now let's change these words around a little bit. Let's do he and hello. This is a little different because he is a substring of hello, and our rule tells us that if one word is a substring of the other, then this substring would precede the other. So if I were to run it again, S1 should precede, right? Giving us a negative number. Now, notice that these negative numbers can be different values, and what's actually happening here is, remember, each letter has a numerical value associated with it, so the compareTo method is doing some math and basically taking the difference of S1 and S2, and that's how this is working to get a negative 0 or positive number. If there's no difference, then we get 0. So again, if I do hello, virtually no difference, so I should get a 0 for the value. Good. And then if I were to make S2 hello with a capital H, remember that capitals precede lowercase letters in this lexicographic order. So if S2 precedes S1 because of the capital letter, then we should get a positive number here. And let's run it. Positive number. Now that we kind of understand how compareTo works, we can use these in if statements. So let's say that I wanted you to print out whichever string came first. So I can have an if statement here, right? Like if S1.compareTo S2, we can't leave it like that, right? Because again, this is going to return a number, and so then I'm saying if a number, that doesn't make any sense. I need a boolean expression here. But I know that I'm expecting negative, 0, or positive, so I can say something like, if whatever number it gives me is less than 0, then I know that this first string, right, S1, is the first word in alphabetical order. So I can say system.out.println S1. So you can do things like this within if statements. So now you've learned how to terminate a program using system.exit0. You've also seen the Boolean operators again and gotten some good practice in with those. We've had a look at the comparison operators and why you can't use that to compare floating points or strings. We saw the equals method and how you could use that to compare two strings or other objects later on. And then we looked at the compareTo method to decide which string precedes another. That's it for this video.